I'd like to talk a little bit about some terminology issues that have come up, what symbols to use, when, and what they mean. So let's get started. As I think I mentioned, we use Greek letters such as mu and sigma to describe population parameters. We use Roman letters to describe sample statistics. So a mean for a population would be given by mu. A standard deviation for a population would be given by sigma. But for a sample, we're not going to use the word parameter, we use the word statistic, and we would use x bar for the sample mean, and we would use s, small s preferably, for the sample statistic. A couple of other things to bear in mind here. Technically speaking, we use a standard error, or SE, to stand for the standard deviation of a sample distribution. And remember, a sample distribution is just exactly that. It is a distribution of multiple samples from a population. So if we have a population that has, going back to our cats and dogs example, if we have a population that has 8 individuals in it, that would be very small and kind of a ridiculous population. But if we had a population that had 8 members in it, okay, then and we kept drawing samples of however many you want. Let's say we're going to draw a sample, as your book does, a sample of 4 individuals each time we sample, okay, then there are a total of 70 samples of 4 individuals from a population of 8. And there's some nasty formulas to show you that, but we take all of those samples together and plot them. That's called a sampling distribution. It's a distribution of samples. To describe the standard deviation of such a sample, we use the term standard error. And the formula for the standard error is given by this. It is the square root of the proportion in the population that are, in this case, that are cats, times 1 minus the proportion divided by n, the sample size. Now, the confusing part is the following. The standard deviation of a set of scores, you all know that. That's given by, let me write down the scores here. That is given by the sum of x minus x bar squared over n minus 1, and we take the square root of that, okay? The standard deviation, however, of a set of the standard deviation of a proportion is not this formula here, okay? The standard deviation of a proportion is given by this formula over here. And I'll just write it out here a little bit differently. Well, actually, I won't write it out differently. We're just going to keep it there like that. Okay? So, it's a little confusing here, and I've seen it written in a bunch of different ways. The formula is the same, whether it is for whether we call it a standard error or we call it a standard deviation of a proportion. All right, the formula is the same. And I'm going to try to be consistent here, and I'm going to try to use standard deviation when I am talking about the standard deviation of a sample taken from a. When I'm talking about the standard, when I'm talking about the standard deviation of a proportion, I'm going to use the word standard deviation. It's important just to bear in mind that the standard error means specifically the standard deviation of a sampling distribution.